Hi, I'm Paul Winter, founder and director of Paul Winter Consultancy, PWCL. We are fundamentally a project management company. We work for investors and developers. We've been founded since 2015. We work on projects in the industrial and energy sectors, ranging from 2 million to 500 million pounds in value. We are working on projects through a project process from early stage feasibility through design and planning, through pre-construction, build, commissioning and handover back to our client or an operational team. We do find ourselves, because we're quite specialized in the market, also doing subtasks to our main core business, which is technical due diligence and feasibility studies as well. So we do tend to offshoot into other parts of the project process or to support other project managers and organizations doing specific tasks as well.
But why is the pre-construction phase, the permitting, the hazards, the design studies, the place where most of the money is really actually lost or made?
So you have to allocate more resource to that process. There's also a cost in the planning process if you're submitting for planning application for a project. There are a lot of regulations. There are a lot of things that we need to overcome, and therefore that requires, for example, our environmental modeling for noise, odor assessments, air quality assessments. We need to do all of this. This requires consultants, planning consultants. All of these people need to be involved. Structural engineers, architects, sometimes all of these people are employed through this process where we're not actually building anything. We're just getting ready to build something. So as you're going through the process, so the costs start to ramp up. And when we're moving into pre-construction, we're engaging with contractors and they will want some money for what we call their front end engineering design. We'll have more detailed engineering studies, process safety studies will need to happen, due diligence, lawyers' costs. All of these costs will mount up the closer you get to the ready to build stage. So you see a lot of these things as a project ramps up. You could be looking at nearly £500,000 of expenditure before you get to ready to build stage on a project. It could be more, it could be less, depending upon the type of project. We kind of look in those sorts of figures. But that doesn't include some of the other costs that the clients may spend on top of that. This is just for some of these consultants working through these processes. And I think when we look at the key things that are the challenges for any project, it's planning risks, dealing with planning regulations, seeking any amendments to planning is a very long-winded process. That isn't to say that we should be able to run roughshod over local authorities, but we're looking at critical infrastructure. We should be looking at how local planning authorities can support as opposed to almost stop us from building anything that we need to do. We need some level of support. We also see that with grid, the local grid, the gas grid connections, electrical grid, network supplies. Support is crucial from those organizations. Not always there. It takes time. It takes a lot of money to get through what they're asking us to do, the hurdles we need to jump through. And then the other critical part is the investment. It's not easy to get investment. It's a process to go through. It's hard to go through investment processes, but it's a challenge that we have to go through, and we have to justify everything, which is why, again, pre-construction, you're getting more detail, more information to make people feel more comfortable with the major investment in the build-out phase of a project. So it's a double-edged sword, really, because you've got to get the information to demonstrate that you're managing your build-out process, that you're managing your project well. But of course, it opens you up for more questions. Yeah.
When we talk about future-proofing a renewable asset, are we talking about the technology itself or the flexibility of the commercial model around it?
An interesting topic. But yes, future proofing is about risk mitigation as well. Future proofing it for the potential to perhaps upgrade to, if we're looking at energy from waste, can we bring in more feedstock? Can we do more processing on an AD? Can we process more gas output? So it's future proofing it to say, where's the market going? What can I do to offset or increase my productivity on that site in 5 years' time, 10 years' time? Can I comply with regulations? Because regulations are changing all the time. Have I got a plant that we have looked at regulation changes? We try to interpret what we think are the future regulations, and that we can say, yeah, we've future-proofed this for potential changes to legislation in 5 years' time. Now, clearly it's guesswork and those things change, but if we've got a plant where we've looked at future-proofing, we've looked at the way it's been put together, we should be able to build in some contingency for future-proofing.
And actually, there's a lot to say about changing regulations, changing policies, changing legislation, and sort of being a bit of almost a fortune teller.
Yes, so legislation changes, and it also changes with government. So different governments of different persuasions comes in with different legislation, regulations, whether they're going to support you, not support you. And you get local regulations as well. So a lot of time is spent in trying to comply with legislation, current legislation, all sorts of things that will impact on a particular project. Stakeholder engagement is one of the key things that we focus on, particularly on some of our projects now, in understanding what the local community is after as well. What are their concerns? Building that in, how we manage local authorities. So yes, a lot of that risk in there again. It's all about risk, managing risk, and key legislation changes are a risk because they could cost the plant a lot of money when somebody changes policy. So baseload is very interesting. I think it's consistent, constant supply of energy, whether it be through gas, whether it be through electricity. I see baseload. Unfortunately, I think we know the failures of nuclear, but nuclear is likely to be a base load because it's a constant flow of energy into the grid. Similarly to EFW and AD, they are constant. They run 24/7 all the time, whereas wind and solar do have this intermittent drop in energy production. If it doesn't blow, if it doesn't, sun doesn't shine, we lose and will drop that energy level. So I see that FW at the moment is a small percentage of the energy produced for the country. I see that could be improved, that could increase, because again, we do generate waste and we haven't got the space in which to dispose of that waste. We might as well use the energy within the materials to get that energy into our UK needs overall. Similarly with AD, as I've just explained in the last question, we have over 6 million tonnes of food waste. We ought to be using that waste, using the digestate produced from that waste as well on our food crops, on our fields as a commodity. And we should be looking at saying, okay, we can have sustainable energy from 2 other sources to support the baseload. There are a number of other factors. There's hydro schemes. There are other tidal schemes that can produce energy consistently as well. And it's looking at that consistent baseload. And I see EFW being part of that baseload mix because they are working 24 hours a day, 7 days a week to produce energy, whether it be gas or electricity. The digestate also has that value, as I've said. The digestate in the tanks, when we're looking at the price of fertilizer, we have a material here that we need to probably look at a value. Price of fertilizer is high. Our digestate in the tank still has nutrient values to it. We can improve those nutrient values and would be a good substitute for fertilizer. At the moment, it's treated as a waste product, and I believe it has a value which people are overlooking at the moment and not prepared to pay. So it takes the waste from both food waste and or crop waste, grasses as well. It has an output of digestate, which could be used on the fields and therefore has a value. And it also, if we collect the carbon dioxide, the carbon has a value to it. And that's another key component part, is the collection of the carbon dioxide. We'll talk about that later. But realistically, there are a number of things that we can do with an AD plant over and above producing just gas and electricity. An interesting question, and depends upon your investor's view of RTFOs. They are a tradable commodity. The GGSS is a stable subsidy that you get for trading your gas and for treating waste. So project RTFOs are traded on the market, and therefore the value can go up and down, and therefore they're not seen in the same security as a green gas support subsidy scheme. However, my view is, looking at the longer term, if we can value the digestate offtake, if we can value the carbon dioxide and increase the revenue streams around an AD plant should be self-sustainable without government subsidy. The problem at the moment is they require government subsidy to take them forward, because we have no value in the digestate, and we have no carbon dioxide market in which to sell into. Now, if we make those revenue streams viable in the future, there is no reason why we can't move away from government support and subsidy. However, again, looking at the subsidy and looking at the investment, it is still far cheaper to invest in this production of gas than it will be to go to the North Sea and drill out the last remaining gas pockets, which is going to get more expensive and higher risk as well for investors, private investors. The AD sector is a maturing market. It's becoming much more professional in its approach. It's no longer seen as just a farmyard tank to put your cow slurry in. It is now becoming much more sustainable as an infrastructure project and an energy project, producing project.
Yeah.
You can inject either gas or electricity into the grid. I know that the national grid for electricity is undergoing a reform. It's undergoing how that process works, and in how they can make sure they've got the right projects available, and they're not just mythical projects where people are trying to secure grid connection. I fully understand that. But it's also how we can support projects to reduce the complexity sometimes, or the red tape that we go through to do the injection of either gas or electricity into the grid. It is highly regulated, or it appears highly regulated from myself, and therefore you have to go through a lot of stages before we get to. Now, we're running on a timetable, so we've got a timetable that we run to, and that timetable also includes trying to keep our costs under control. So we don't want to extend our timelines, and sometimes where we find a problem is in the network operates so slowly in response, and the utilities people operate slowly in response, that we find ourselves having to wait weeks, sometimes months, before we get responses. The same can be said for Environment Agency when we're looking for permits. Their response times are very long. I understand they're under pressure. They have much more to think about than I do, probably. But we look at it and say, okay, they seem to be taking an inordinately long time to respond to things, to process things that we want to move quicker. And I think if we could unbottle that and say, look, let's stop this hurdle. Let's be able to support projects. Let's get the network working. Let's get the timetable improved. Yes, we've got to upgrade it, but we've also got this opportunity, if we work with industry, to unbottle these hurdles, get away from these hurdles, and get projects moving quicker. I think a lot of people are put off because the cost increases in this process before we get to build stage because of those utility connections, because environmental permits, because of local authority regulations, planning regulations. It takes an inordinate amount of time, and that's when the costs rise, and that's what puts people off in investment.
And actually, the further you are away from where the energy is needed, the arguably the more expensive it is to get it there.
And it comes back to our original question about AD, that we can build an AD plant on a farm, but if it's not near a grid connection, we've got to take that output somewhere, somehow. So we're always looking at the moment to build projects where there is a gas main, and most of the time there is, but there are other opportunities in other areas where there just is no gas network, or there's a reduced gas network, or something that we can inject into. So although we look to say, okay, we should be able to take 6 million tons of food waste, there are a number of facets or constraints around how we can build an AD project, from planning, getting through planning when people don't want you to build a AD perceived smelly, which is not the case now, AD plant, and the regulations, the investment hurdles. There are so many hurdles to get through to get this underway. So although we say we could do this, treat this 6 million tons of food waste, 10 million tons of organic waste, the answer is we have so many challenges and hurdles to overcome.